Hi there, in this video clip I want to talk about the reactions of acids. But before I go into the actual reactions, let's remind ourselves of the names and formulas of some of these acids. HCl, hydrochloric acid. Nitric acid, HNO3. Sulfuric acid, H2SO4. When these react with things, they neutralise, and the product is, one of the products is always a salt. So if I say hydrochloric acid reacts with so and so and so and so, one of the products is a salt, and the salts of hydrochloric acid are called chlorides. The salts of nitric acid are called nitrates, and the salts of sulfuric acid are called sulfates. So if something reacts with nitric acid, one of the products is probably going to be a nitrate or a chloride in the case of hydrochloric acid. Let's get on to the first reaction I want to speak about, and it is acid plus metal gives you a salt plus liberates hydrogen gas. So if I add an acid to a metal, it probably starts to fizz, and this gas that's coming off is hydrogen. But depends on the position of the metal in the electrochemical series, the reactivity series, but most metals combine with an acid to form a salt plus hydrogen. Let's look at an example. Magnesium reacting with hydrochloric acid, it forms magnesium chloride and liberates hydrogen gas H2. I just balance that up now. Try to. So magnesium reacts with hydrochloric acid to form this salt, magnesium chloride plus hydrogen. Let's look at a second one. Zinc plus 2HCl reacts to form ZnCl2 and liberates hydrogen gas. These are the salts liberating hydrogen gas. That's the first reaction. Acid plus metal gives you a salt plus hydrogen gas. Let's look at the second reaction, which is acid plus alkali. Gives you a salt plus water. Acid plus alkali gives you a salt plus water. These alkalis are generally metal hydroxides. So, acid plus alkali gives you salt plus water. The neutralisation product, when acids react with something, like I said previously not long ago, gives you a salt. Let's look at an actual example now. Suppose I took hydrochloric acid, H plus an alkali, sodium hydroxide, a metal hydroxide, sodium hydroxide. That gives you a salt plus water. That gives you sodium chloride plus water. Acid, alkali, salt, water. And let's look at another one. Suppose I say I've got this time potassium hydroxide plus sulfuric acid. It's going to give me K2SO4 plus water H2O. Again, acid plus alkali gives you salt plus water. Now let's look at a third reaction. Acid plus carbonate. Acid plus carbonate gives you salt plus water plus carbon dioxide. Carbon dioxide. I can't spell. Let's look at an example of this. Suppose I took chalk, calcium carbonate, marble chips, calcium carbonate. There's calcium carbonate reacting with hydrochloric acid, say HCl. That's going to give me calcium chloride plus water, H2O plus carbon dioxide. Acid plus carbonate gives you salt, water and carbon dioxide. And the final reaction of acids is that with which I'll call a base. And the base can be an insoluble oxide. For example, if I took, let me write that down, acid plus an oxide, or an insoluble hydroxide, or an insoluble hydroxide, that's going to give me a salt plus water again. Let's look at an example. Here is copper oxide reacting with sulfuric acid H2SO4. I know it's going to give me a salt plus water, and the salt is copper sulfate plus water. Acid plus base gives me salt plus water. And if I took the insoluble hydroxide, this of copper hydroxide, insoluble that is, plus hydrochloric acid, it's going to give me copper chloride plus water. I could balance it up, but I've not, because you don't need to do it at this sort of level. But that is the fourth reaction. So what I've said to summarise is this: acid plus metal, salt plus hydrogen, acid plus alkali, salt plus water, acid plus oxide, salt plus water, and acid plus carbonate gives you a salt, water and carbon dioxide. Most salts are soluble I'll say again, most salts are soluble, except, there's always exceptions to the rule, plus the carbonates of sodium, potassium, ammonium salts, change my pens, are not soluble. They're not soluble. Most chlorides are soluble, except for silver, for example. Most sulfates are soluble. Most of these sulfates are soluble, except for calcium and barium sulfates. Most of them are soluble. Generally, what I'm trying to say is most salts, nitrates, chlorides and sulfates are soluble, but there are a few exceptions. And I'll give you a clue. The fact they are insoluble helps us to find out which cations a solution contains. I'll tell you a little bit about that now as I'm here. If I took a solution of a chloride and I add it to a solution of silver nitrate, okay? Suppose I say I've got a solution of so-and-so. Does it contain chloride ions? The answer is I'd add a few drops to a solution of silver nitrate, and if a precipitate is formed, I know that my solution X contains chloride ions. I mentioned barium, and if I took a solution of barium chloride and I've got a solution X, and I know, okay, I'm going to tell you it contains sulfate ions. I've got my solution and I say to you, do you think it contains sulfate ions? And you say, add it to barium chloride, and if I get a white precipitate of barium sulfate, I know it contains it. But I'll tell you more about that when we're doing tests for anions. And that's it, folks.